Have you ever watched one of those CNC lathes slicing through metal and thought, why doesn't it just take one huge bite, get it done faster? Seems logical, right?
Yeah, I mean, on the face of it, why all the little steps? It looks slower.
Exactly. Well, today we're diving deep into CNC lathing and this key technique called staged infeed. You might also hear called incremental feeding or step feeding.
Right.
And we're going to figure out why this approach, which seems a bit slower, is actually often the smarter, safer, maybe even faster way in the long run, to get precision and keep the equipment happy.
It's a bit like sculpting, isn't it? You wouldn't just take a massive whack at a block of marble. You'd chip away carefully.
That's a great way to put it. And for you, the learner, tuning in because you want those aha moments and efficient insights, this should really demystify a core manufacturing idea. Whether you're like prepping for a meeting about machine parts or just trying to understand industrial stuff, or maybe you're just fascinated by precision engineering. Understanding staged infeed gives you a real insight.
Yeah, it's fundamental. We'll break it down, keep it clear, look at the principles, and honestly, some surprising benefits.
And we're drawing our insights today from a really good article called Why is Staged Infeed Often Used on CNC Lathes?
That's the one.
So our mission today, let's figure out why staged infeed is such standard practice in CNC lathing. What are the real benefits for the part? The machine's life, the tool.
Okay, let's jump in. That first question. Why not one big cut? Speed seems king.
It does, yeah.
It really does. But the reality, as the article points out pretty clearly, is trying to rip off too much material at once. Well, it can cause a whole cascade of issues.
Like what kind of issues?
You could easily damage your cutting tools. They're precise, sometimes delicate things. You put enormous strain on the lathe itself, the machine components. And critically, you might just end up with a part that's, well, scrap. Doesn't meet the spec.
Ah, okay. So it's that classic more haste, less speed situation, potentially.
Exactly. The number one benefit, the core reason for staged infeed, is that it dramatically lowers the cutting forces involved. By taking smaller bites, the tool just doesn't meet as much resistance on each pass. This protects those sharp cutting edges, stops them chipping or wearing out too fast, and it also protects the machine, the bearings, the slides, all that complex gear.
Okay, protecting the hardware makes immediate sense. But how does taking smaller bites actually make the part better?
Well, there's a really direct link. Lower forces mean less vibration, less chatter, and crucially, less deflection.
Deflection, like bending.
Yeah, exactly. The tool can bend slightly, the workpiece itself might shift a tiny bit in the chuck, even the machine structure can flex under heavy load. Less force means less of all that.
And less bending means more accuracy.
Precisely. You get much more accurate final dimensions and usually a much nicer surface finish too. The article we're referencing really highlights this for things like bigger threads or when you're cutting really tough materials.
So for the really demanding jobs, the high precision stuff, staged infeed isn't just a nice to have, it's kind of essential.
It really is. And there's another piece too, Chips.
The little bits of metal that come off.
Yeah, the swarf. Smaller cuts tend to make smaller, more manageable chips. They break nicely and get flushed away by the coolant easier. Big, stringy chips from a heavy cut can get tangled, jam things up, even damage the surface finish you're trying to achieve.
Okay, so it helps keep the whole cutting zone clear, too. Makes sense. So kinder to the tools, kinder to the machine, better parts, better chip control. Now, the article really digs into why this is absolutely non-negotiable for tight tolerances and those really difficult materials.
Right, because when you're talking super alloys, titanium, hardened steels, these things really fight back against being cut.
Yeah, I can imagine.
Getting those super precise measurements, those tight tolerances, it's a real challenge. Staged infeed gives you the control you absolutely need.
So trying to just power through with one big cut on titanium, say, is just not going to work well.
Pretty much asking for failure. The article breaks it down nicely. First, back to those cutting forces. Tough materials. They generate huge forces, sometimes very suddenly. A single deep pass can literally bend the tool away from the cut path. It can make the workpiece move slightly, even if it's clamped tightly, or, like we said, flex the machine itself.
That flexing is hard to picture on such solid machines, but I guess the forces are massive.
They really can be. So staged infeed uses roughing and finishing passes. Roughing takes off the bulk, maybe with slightly bigger but still controlled cuts.
Getting rid of the excess quickly?
Yeah. But then you have the finishing passes. These use much smaller depths of cut, tiny amounts.
And that's the key.
That's the key to slashing those forces right down. Less force, way less deflection of the tool, the part, the machine, and that translates directly into hitting those tight dimensional targets.
Okay, so it's a gradual refinement. Makes sense.
Yeah.
But it's not just about force, is it? What about heat?
Heat. Yes, huge factor.
Yeah.
And especially with these tough materials, machining generates a lot of heat, friction mostly. And many of these advanced alloys, things like titanium or Inconel, they're actually poor conductors of heat. So the heat doesn't spread out quickly. It concentrates right there at the tool tip.
Ooh, like a little hot spot. That can't be good for accuracy.
Exactly right. That intense local heat can cause the material to expand, the tool to expand, even parts of the machine. Thermal expansion throws your dimensions off.
So how does staged infeed help with the heat?
Well, smaller cut, less material being deformed per pass means less heat generated per pass. Simple as that.
Okay.
Plus, having multiple passes gives more time for the coolant to get in there, do its job, and carry the heat away. It keeps things more thermally stable. Essential for precision.
Right. More chances to cool things down between cuts. What about the poor cutting tool itself, though? Bashing against hard metal must take its toll.
Oh, absolutely. Tool wear is a massive issue with abrasive or hard materials. A dull or chipped tool just can't cut accurately or leave a good finish.
Stands to reason.
So staged infeed strategies often involve using specific tools for finishing, maybe a brand new insert, or at least a fresh edge that hasn't done the heavy roughing work.
Ah, so you might use a tougher, maybe slightly less sharp tool for roughing?
Exactly, built for strength.
And then switch to a really sharp, maybe more delicate tool for the final precision pass.
Precisely. You preserve that critical sharp edge for when it matters most, hitting the final dimension and finish.
Smart. And the article mentions something else. Work hardening.
Yes. That's a tricky one. Some materials, certain stainless steels, for instance, actually get harder as you cut them. The mechanical stress of the cut changes the material structure right at the surface.
So the material you're about to cut on the next pass is harder than the stuff you just cut.
Exactly. If you take too deep a cut, you create this hardened layer. Then your next cut struggles, forces go up, wear increases. It's a vicious cycle.
Wow. How does staged infeed deal with that?
By carefully controlling the depth of the finishing pass, you aim to make that final cut below any potentially work-hardened layer left by the previous pass. You get into the softer, original material underneath.
Clever. So you're always cutting predictable material on that crucial final pass.
That's the goal. Consistent material removal, plus the smoother finish you generally get with staged finishing cuts, also helps in holding those tight tolerances. It all interconnects.
It really does paint a picture of needing very careful control, especially with these challenging materials.
Absolutely. And, this careful control doesn't just benefit the part being made, it's also hugely beneficial for the CNC lathe itself. We're talking about big investments here.
Right. These machines aren't cheap. You want them to last and stay accurate.
Definitely. And just constantly hammering away with really heavy, aggressive cuts, that takes a toll. It wears out critical components faster than they should. Things like the spindle bearings, the turret mechanism that changes tools.
So staged infeed is kind of like preventative maintenance built into the cutting strategy.
You could definitely see it that way. It protects those vital, high-precision parts.
How exactly does it reduce that wear and tear?
Well, think about peak loads and shock. A single massive cut hits the machine hard, like a sudden jolt. Big forces, both pushing into the workpiece, axial, and sideways, radial, hitting the spindle bearings, stressing the turret as it holds the tool.
Right.
Do that over and over, and those high peak stresses cause fatigue. Bearings lose their superfine precision. The turret might not index quite as perfectly over time.
Degradation creeps in.
Yeah. Staged infeed breaks that massive load down. Each smaller pass exerts much less peak force. It's a gentler process overall. Less stress, less fatigue, longer life for those critical systems.
So it's avoiding those big shock loads, like smoothing out the bumps in the road for the machine.
That's a good way to think about it. And related to that is vibration. Heavy cuts almost always cause more vibration. You can sometimes hear it, feel it.
Chatter, right?
Right, chatter. Bad for the surface finish, obviously. But that vibration also shakes the whole machine. Think about driving on a really rough road. Constantly bits loosen up, things wear out faster.
Yeah, rattles and squeaks appear.
Same idea inside the machine. Those smooth, light cuts in staged infeed generate far less vibration. It's a calmer process. That helps preserve the machine's built-in accuracy and reduces stress on joints, fasteners, everything.
Less shaking means less wear over time. Makes perfect sense.
And back to heat again, briefly. Less heat generated per pass isn't just good for the part's accuracy, it's also good for the machine. Less thermal stress on the machine structure helps maintain alignment, which is vital for accuracy and longevity.
So it all connects forces, vibration, heat controlling them protects the machine too.
Absolutely. And the article makes a practical point. Shops that really embrace staged infeed often report fewer unscheduled breakdowns, lower maintenance bills, especially for spindles and turrets. It pays off.
That's a strong argument. Okay, so we're taking these smaller, controlled cuts. Does the specific type of cutting tool become even more important then?
Oh, definitely. Choosing the right tool is always critical in machining. You can't get away from that. Even with a perfect staged infeed plan, the wrong tool will still cause problems. Poor finish, short life, you name it.
Right.
But with staged infeed, you can really optimize by matching the tool characteristics to the stage of the process. Different tools shine at different jobs.
So you wouldn't just use one all-rounder tool for roughing and finishing?
You generally wouldn't get the best results that way, no. The article clarifies this well. For roughing passes, remember, the goal is fast material removal. Strength is key.
Okay.
So you'll use inserts, the little cutting tips that have stronger edges, maybe what's called a negative rake angle or a honed edge, slightly rounded for toughness. The carbide material itself will be a tougher grade, resistant to chipping under those heavier loads.
Makes sense. Built tough for the heavy lifting.
And the chip breaker geometry on the insert will be designed to handle the bigger chips produced during roughing, curl them up, and break them effectively.
Got it. So strong and focused on removal. What about when you get to the finishing stages?
Then the priorities shift completely. It's all about accuracy and surface finish. The cuts are much lighter.
So you need sharpness.
Exactly. Sharper cutting edges are crucial. Often positive rake angles, which cut more cleanly with less force. You might use inserts that are precision ground all around the edge for maximum sharpness.
Finer instruments.
Definitely. Chip control is still important, but the chip breakers are designed for the smaller chips from finishing cuts. And for that final pass, you might even use special wiper inserts.
Wiper inserts.
Yeah, they have a tiny flat or a special curve on the trailing edge that basically smooths or wipes the surface as it cuts, giving a really excellent finish. Plus, you'll see specialized coatings on finishing inserts things to reduce friction or boost wear resistance right at that fine edge. And sometimes, like for cutting coarse threads, you might use multi-point inserts to spread the load even during staged cuts.
It sounds like a whole science just in selecting the right insert for each pass.
It really is. And don't forget, the tool holder needs to be super rigid, especially for finishing, to prevent any vibration that could spoil the accuracy or finish.
Right.
The analogy the article uses is good. Roughing tools are like heavy earth-moving gear. Finishing tools are like surgical instruments.
That paints a clear picture. So matching the tool to the task at each stage is key.
Absolutely fundamental for getting the best out of a staged infeed strategy.
Okay, this all makes staged infeed sound incredibly logical and beneficial. But I can still hear someone thinking, isn't it just slower? Do I really need to do this for every job? Why push for it as a primary strategy?
That's a fair question, because sometimes it looks slower on the stopwatch for a single part. But think about the risks of not using it when you should. Broken tools cost money and downtime. Damaged machines cost a lot of money and downtime. Scrapped parts waste material and time.
Right, the potential costs of failure are high.
Very high. So viewing staged infeed as a default, primary strategy is often about risk management and consistency. It provides that fundamental control.
Control over what, specifically? Remind us.
Primarily managing those cutting forces that protects the tool, protects the machine. That's job one. Second, optimizing heat control, less heat per pass, better cooling, vital for accuracy.
Okay.
And third, directly improving accuracy and surface quality. Lighter finishing cuts mean less vibration, less deflection, better results. And some folks argue that while roughing might take a fraction longer, the time saved from not breaking tools or reworking parts often makes it faster overall.
The total time, cradle to grave for the part, might actually be less.
Exactly. And there are other efficiency gains, too. Better chip management, like we talked about, especially for tricky things like big threads. It just makes the whole process run smoother, more reliably. It also makes the process more adaptable. Got a rough casting with an uneven surface. Staged infeed lets you take a cautious first cut, dealing with interrupted cuts where the tool hits air, then metal. Again, smaller, controlled steps are safer.
So it handles variation better.
Yes, across different materials, different part shapes. And modern CNC controllers are brilliant at this stuff. They can manage complex multi-pass routines, varying the speeds and feeds precisely for each stage. It really leverages the power of the CNC.
So it fits perfectly with automated precise manufacturing.
Absolutely. Now, for a really simple part in easy-to-cut material, maybe a quick rough and a single finish pass is fine, a basic two-stage approach.
Sure.
But for anything more complex, tighter tolerances, tougher materials, a detailed multi-stage in-feed plan becomes essential. It's really about planning the entire cut, start to finish, for control.
It's a strategic approach to machining, not just a brute force one.
That sums it up perfectly.
Well, this has been incredibly illuminating. Just to wrap up then, staged infeed isn't just about taking small cuts. It's a fundamental strategy for protecting tools, protecting the machine, guaranteeing part quality, both accuracy and finish, extending machine life, and handling all sorts of materials and complexities.
Couldn't have said it better myself. And hopefully for you, the learner, digging into this gives you a real sense of the thought and precision that goes into making things well nowadays, why those seemingly small steps actually lead to much bigger, better results.
Absolutely. It makes you appreciate the process. And here's a final thought to maybe chew on. As CNC tech gets even smarter, faster, more sophisticated, how might stage and feed itself evolve? Will we see AI optimizing these strategies in real time? What new materials might force us to rethink how we apply these fundamental ideas?
That's interesting. Future challenges for a core technique. Definitely food for thought.